Before we go into the discussion on how lift is generated and the other forces of flight, let us first consider the principles which govern these forces. Firstly, let's talk about the continuity equation. The equation is as follows. Mass flow input equals mass flow output, which means that the mass input into a system equals the mass output out of the system. Mass flow rate is the amount of mass going into the system per second. We can further analyze the equation by giving a clearer definition. Mass flow rate is the function of density times velocity times area. The equation obeys the law of conservation of mass, which states that matter can neither be created nor destroyed. Since our fluid is incompressible throughout the system, we can assume density to be constant and hence simplified to velocity times area, neglecting density in our equation. So how is this equation applied? We will consider an example. But before that, let's remember a simple rule. A specific mass entering a system within a given time will have to leave the system with the same mass within the same amount of time. Given the example where water is entering a nozzle where the output has a smaller area than the input, according to the equation, the mass flow rates of the output and input have to be the same. Therefore, with a decrease in the output cross-sectional area, the velocity of the output will have to increase in order for the law to remain true. A smaller output area of a nozzle as depicted will result in a slimmer and faster stream of water.